All right, so let's do this. Chapter 2. Oh my goodness. I forgot to do this and do this. All right, now we're ready to go. Let's make sure it works. Okay, good. I'm just going to start off with an example. I'm not even going to talk about it. I'm just going to start off with an example. Example 1. What we're going to do is we're going to solve a system of equations. This thing right here is solving systems of equations. It means we have two different equations. Each equation has two variables. Here's something that maybe I was taught in high school. Maybe I wasn't paying attention. That could be a valid reason. But I remember in college them telling me this, and I thought, what? I never even heard of that before. If you're solving for two variables, you must have two equations. If you're solving for three variables, how many equations do you need? You need three equations. So depending on how many variables you are solving for, then you have to have that many equations. All right. Up to this point in Algebra 1, you just had one equation and you had one variable. I don't know, for instance, I'm not even going to do this. 3 plus 2 equals, let's go 5. Okay, if you had something like this, there's only one variable. So you only need that one equation. Okay, if you got that one equation, you should be able to solve for x, no big deal. But this time we're going to have a system of equations, and we're going to have how many? Two variables. So that means we're going to have two equations. And we're going to do it a couple different, actually 3 different ways. The first one, we're going to solve by graphing. So the first one, solve by graphing. The graphing's not difficult. They're just lines. They're just straight lines, linear. It's not that big of a deal. But I want to show you what we're doing when we solve by graphing. Let me give you the equations. Here it is. It's 3x minus 2y equals negative 6. Now, sometimes solving by graphing is not very accurate because you don't really land on a point where you know where it is. It's like halfway between the grid marks or somewhere in between the grid marks, and you just have to make an estimation. So it's not always the best way to solve, but it is a way to solve. This book doesn't do it, but I see a lot of books do this. They put a little brace around it just to show that those two go together. You don't have to. They don't put it in the book, but I'm going to put them on mine just because that's what I'm used to. So solve by graphing. What does that mean? That means we're going to graph both of these equations. And then if these equations intersect each other, the point of intersection, it's a point, right? It's an x and it's a y. And guess what that x and y is? The answer, okay? It's the solution to both of these equations, okay? It's the point of intersection, okay? It's what they have in common. So what these two lines have in common, okay, whatever the x is, whatever the y is, you could plug it back in here and they should work with both equations. Does that make sense? All right, so we're going to graph them. The first one, what are you going to do? Get y by itself. So I would go negative 2y. What would you do in your head? Get rid of that 3x. Subtract a 3x from both sides. Everybody see that? All I did was move this over to the other side. Divide by negative 2, divide by negative 2. All right, that cancels. Y equals, what's that? Positive 3 over 2x plus 3. It's not really my answer. I'm going to graph that. I'm just going to put it in a box just for safekeeping. I'll come back to it in a few minutes, okay? This one's a little bit easier to solve, to get y by itself. By the way, I didn't even say this. Why did I get y by itself? Because slope-intercept form, exactly. Slope-intercept form, I'm going to graph it. That's why I solve for y. I should have said that earlier. All right, solve for y here. I'll just put it here. Y equals what? Get rid of the x. That means minus x. Keep the minus 2 over there. And there we go. It's slope-intercept form. So what we're going to do is we're going to take those and we are going to graph them. I got this nice little graph thing here. If you want to use graph paper, you can. You don't have to. There's not going to be a whole lot of these. But if you want to be accurate, graph paper is the best way to go. So if you have graph paper, I've had people like cut out the graph paper and like tape it onto the paper if you want to do that. Or if you just want to do your whole homework on graph paper, all right? That's fine. No extra credit. All right, so let's graph this and let's find out where they intersect each other. So graphing shouldn't be hard. Let's do this first and what we did. What's the what do we graph first? Y-intercept, 1, 2, 3. And then the slope, 3 over 2. So I go up 3, 1, 2, 3. To the right 2, 1, 2. Right there. All right, and I connect the points about like that. And about, oops, grab it, there you go. And about like that. Now, if you wanted to really make sure that you were, because sometimes you can slant the line a little off. You think it's hitting the 2 points, but it could go like this, and still looks like it hits the 2 points. So instead of going up 3 and to the right 2, I could go what? Down 3, 1, 2, 3, and to the left 2, right? So it should hit right there. So I was off just slightly. So there we go. All right, that's a little bit better, right? The wider I have those points spread out, the more accurate my graph's going to be. All right, so there's one graph. All right, let's do another graph. Let's do it in a different color. All right, y equals negative x minus 2, so the y-intercept is at negative 2. Slope is negative 1, so you could, I don't know, rise 1 and run negative 1. Or you could rise negative 1 and run positive 1, right? Or, and you could do this. Let's do it one more time. Rise 1, run negative 1. Look at that. It hits right there. So you know exactly where it should hit. Okay, so, but we'll graph it anyway. Now again, what do these 2 points have in common? They have this point right here in common, don't they? That's where they intersect each other. And this was an easy one because it works out perfectly when you go up and over. When you go up and over and all that, it lands dead on right there. So there's no doubt in our mind that's our point. So what is my answer then? My final answer is, and we write it as an ordered pair. Don't just write x equals y equals. Write it as an ordered pair. So what is that point right there that I circled? Nobody? Come on. Negative 2, 0. Thank you. Negative 2, 0. And that is the answer. Okay? That means x equals negative 2 and y equals 0. But when you do system of equations, you always write your answer as an ordered pair. So let's make sure that we do that. By the way, I just thought about this. I said tomorrow we're going to be doing 3 variables, so it's not going to be an ordered pair. What do you think it's going to be? If there's 3, there's 3. Pair is 2. Means 3. Does group always mean 3? What means 3?
Trio.
Trio. Okay, it does. 4 does not mean. It's a triple. It's an ordered triple. Very good. All right. But we're going to do that tomorrow. All right. So that's one way to graph or to solve. All right. Solve by graphing. We solved it. If you wanted to, you could put them in. Right. Put in. Yeah, we can do it. Put in a negative 2 in for x. 3 times negative 2 is negative 6 minus what? 2 times 0. 0, right? So what's negative 6 minus 0? It's negative 6. Does negative 6 equal negative 6? Yeah, of course it does. Let's put the negative 2 in for this x. Negative 2 plus 0 is negative 2. Does it check? Yep, it checks. We're good to go. All right. You don't have to check them. I'm not going to make you check them. But a lot of times it's good to, if you have the time, to do that. All right, let's do another one. I'm skipping the order they do in the book. They go to elimination. I want to go to substitution. I think substitution is a little more, a little more natural for you, all right, because you've done a lot of substitution stuff before. So I'm actually skipping ahead to example 3. We'll go back to example 2. Actually, I'm not even going to do the example that's in the book. I looked at that one. They put some decimals in there. That's okay for a problem like in the exercises we have to do for the homework. But if you're just trying to explain something, I'm not trying to worry about the decimals, okay? So I picked a couple problems that I found that are a little bit better. But that's for elimination. This is substitution. So they will actually tell you, it's supposed to be a U, use substitution to solve. You guys have done a lot of substitution in the past, but this might be a little bit different. I don't know. I'm sure you did this in Algebra 1. Do you remember doing this stuff in Algebra 1? Oh, Algebra 2. Yeah, you're in pre-calc, right? Yeah, you absolutely did this in Algebra 2 for sure. You hated it? Oh, my word.
Wait, you needed output too? Oh, yeah.
All right, here we go. And then again, the book doesn't put this, but I like to put it just to show that they're grouped together. All right. Now here's what we want to do. We want to do some substitution. We want to replace one of the letters with something else, with another letter, okay, or another value, I guess you could say it. So, do I have like x by itself, x equals something?
Yeah.
Do I have y equals something? No, in either one of these. But which one do you think would be the easiest to actually get x by itself or y by itself? The bottom one. Yeah, the bottom one, absolutely. Okay, and I would probably, again, you could if you wanted to. Shh, let me talk. Okay, that joke's so old now, all right? So look, you could, if you wanted to, solve for this x, or you could solve for this y, or you could solve for this x, or you could solve for this y. I would pick the one that's the easiest to solve for, all right? Unless you're, somebody that likes to do things the hardest way, okay? But I like to do things the easiest way, so I will solve for this x. So if I solve for this x, Brady, you need to leave? Doesn't look like it. So look. So what I would do, I would solve for x. You could solve for this y, that would have been just as easy, okay? But I'm going to solve for this x, okay? Just add a y to both sides. I mean, I didn't say it, but I figured you knew how to do that. All right, so just add a y to both sides. Okay, I got to go through every step. So add a y to both sides. All right. Now what I'm going to do is this. I'm going to take what x is equal to, and I'm going to replace it, not back into the one where I got this equation from, but put it back into the other x value. So we're going to take that and put it in to that x right there. And then we're going to work it out, and then you're going to find out that you have just y's available. And then you can solve for y. So that's what we're going to do. We're going to go 2 times x, but what is x? Y plus 2. And then just finish off the rest of that and then solve for y. Everybody with me? So distribute. Oops. All right, so that's 5y. Subtract 4. You get 4. Divide by 5. Y is what? 4/5. Okay? Again, that's not my final answer because I want 2 answers. I want x and I want y. So I'll just put that in a box right now, just for safekeeping. And now what I can do is put this, I could put this into several different places. That y, I could put it in for this y if I wanted to, but really, do you want to put it in for that one? Absolutely not. You could, it'll work, but I wouldn't want to. All right? Right here, you already got x by itself, don't you? So let's just put it in for this y right here. So x equals y, which is 4/5, plus 2 over 1, but I'm going to write it with a common denominator of 5. So what's that going to be? 10. And then I get what? 14 over 5. And that's what x is equal to. Put that in a box. Now, a lot of people will just circle both of those, x equals, y equals. But again, this is a system of equations, and we want to put it as an ordered pair. So what do we put first? 14/5, and then you put the y, 4/5. That right there is your answer, and I circle the answer. You don't have to put this x and y in boxes like I did. I just did it just to, okay? No. You just have to solve.
Did it say graph?
It says use what? What does it say? Use substitution. And we just did. All right, now, let me show you elimination. Substitution is usually the one that you kind of click with a little bit easier. Elimination is the one that may be a little bit different for you. So this isn't, I'm going to call it example 2. It's not really example 2 in the book. All right, I'll call it 2A because I'm going to do 2 of them. I'm going to do the easiest one possible. Then I'm going to do one where you have to think a little bit about it. All right, and do an extra little thing. I'll show you what I'm talking about when we get to it. So this one says solve by elimination. Now, let me finish writing that. Solve by elimination. You could, this problem right here, you could probably solve by substitution. You could probably solve by graphing. Okay, either way would be pretty easy. But they specifically want you to do it by elimination just so you'll learn the different ways to do it. There are some systems of equations that are just tailor-made for elimination. Some are made for substitution. Some of you look at them and you're like, oh, I'm going to definitely use substitution on that one. Or you look at it, you're like, oh, I definitely don't want to use substitution on that one. I'm going to have to go to elimination, all right? There's probably rarely a time when you're like, oh, I want to solve that by graphing. Probably not, but that's what we're doing here. All right, so let's do it. 7x plus y equals 9. Then 5x minus y equals 15. All right, these go together. So I like to put them in a brace. You don't have to. The book does not. Now, elimination. You've probably seen this before. You probably saw this in Algebra 1 and in Algebra 2. But there's a rule that says if you have these systems equations like this, you can line them up and you can add up all the columns. All right, I'm allowed to add this, this, and this. Because whatever you do to one side, you do the other side. So if I add these together, then I add these together, I'm good to go. All right, there's another more of a little bit of a lengthy explanation, but that's good enough. All right, so let's add up our columns. Let's do that. And why would I do that? Because look, this is perfectly made. This is exactly made for elimination. That's the easiest way to do this problem. Because I got a positive y and a negative y. What happens when I add those together? What happens to the y's? They cancel out, or they what? Give me a word. Eliminate. That's right. They eliminate. They go away. They cancel out. Okay, that's why they call elimination. This problem actually isn't just all elimination. It's actually the first step is elimination. The second step, we're going to go back to substitution. So you could call this elimination / substitution, but they call elimination if that's our first step. So what I'm going to do is I'm going to add up all the columns. If I add up that, I get 12x. I add up this, they cancel out. We got rid of the y's. That's good because I only want one variable, right? And then I can find the other one. And then that equals what? 24. X is 2. All right, it's not my final answer. Just put it in a box. Right, now what we're going to do is now we're going to go do some substitution. You could put it into the top one. You could put it into the bottom one. Let's put it in the top one since y is already positive right here. Let me get rid of the little X out mark thingy. Okay. So, but it doesn't matter. You could put it in for the x multiplied by 7. You could put it in for this x multiplied by 5. But this y is already positive, so I'm just going to keep it like that. So what do I got? 7 times 2 plus y equals 9. See what I'm doing? Again, it's just a simple substitution in for either one of these. It doesn't matter. You could put it in for either one. You're going to get the same exact answer. Right? Even though they're completely different numbers, you'll get the same answer no matter which one you put it in. If you don't believe me, try it. I'm not going to do it just for the sake of time. So this is what? 14 plus y equals 9. Y equals, subtract a 14 from, 14 from both sides. And what's that? Negative 5. Oops, my thing would write. Negative 5. All right, so now how do we write our final answer? As an ordered pair, 2, negative 5. That is how you want to write your answer right there. Pretty simple, isn't it? Yeah, that's the easiest. That's the easiest version of elimination. Okay? They get harder. I'm not going to give you like the hardest version of it, but I'm going to give you slightly more difficult. And hopefully you can do the rest of them with this. So this again says solve by elimination. I'll write that in there. Solve by elimination. All right, and here it is. This is 3x plus 4y equals negative 1. And then I got 6x minus 2y equals 3. All right, there you go. Can I just add up the columns and automatically just eliminate one of the variables? No, because if I add them up, I get a 9x, I get a 2y, and I still got another equation with 2 variables. So I haven't really accomplished anything. Okay, what I want to do, I only have to do one step here. All right, this is not that hard. Sometimes they get a lot harder than this. All right, but on this one, what I want to do is I want to pick either the x or the y. Which one do you think would be the easiest to eliminate? The x or the y? The x? Why the y? I agree with you with the y. Why? WHY. Yeah, one's positive, one's negative. Exactly. Okay? So look, this is positive, this is negative. All right? Already it's set up when I add them up, they're going to add up to 0. I could eliminate the x's. That's perfectly fine. All right? But I'd have to make one negative. Okay? And not just negative. Like, look at this right here. I'm going to have to change one of these. In order to add them up and they add up to 0, which one am I going to have to change so that they are the same numbers? The 2. And I'm going to do what to it? Good. I'm going to multiply this by 2. So that means I can't just multiply that by 2 and nothing else. I got to multiply everything on the left side by 2 and everything on the right side by 2. All right? Just got to still, go by those basic algebra rules. Let's rewrite it. I got 3x plus 4y equals negative 1. And then what's this going to be? 12x minus 4y. That's what we were trying right there. That's the whole reason why we multiplied everything by 2. So we got that to be a negative 4y equals 6. Yeah. Because then they'd both be positive. And when I add them up, I can't get a 0. So if I multiply this by negative 2, it's going to be negative 2 times negative 2y, which is plus 4y. Then I'd have plus 4y plus 4y. Okay? So in order for them to add up to 0, one's going to have to be plus, one's going to have to be minus. All right? So that's why I wanted to keep this minus. Now, I could have done this. I'm not going to, well, maybe I will pursue it after we do the answer. I could have eliminated the x's. What would I have to do in order to get those x's to be the same thing, but 1 plus, 1 minus? By negative 3? Negative 3 times 3 is 9. Negative 9. If I add those up, I want this to be the same as this. What do I have to multiply this? Not by 3, by 2. Not just by 2, but by, this time, I will multiply. Now, what I'm doing in yellow right here, it's an alternative. You don't have to do both of these things. Everybody with me on that? I don't want to confuse you. But if you wanted to do an alternative to this red one, you could do the yellow. Then what would you get? You get negative 6x, right? And this would be a 6x. And then the x's would eliminate. You'd get y. Then you plug it in to get x. Does that make sense? All right. Hope I didn't confuse you with that. I have a feeling I might have. All right, so let's continue with this, with the red. All right, now look what we did. We made this a negative 4y, so when we add these up, they'll add up to 0. So they cancel. What's this? 15x equals 5. Divide by 15, x equals 1/3. All right, we're not finished. We got to solve for y. Now again, we got x. So I could put x in for any of those other equations. I'd probably put it into the one that is probably like the easiest one. I don't know, 3 and 4, negative 1. They seem like they have kind of the smaller numbers. So let's put it into that. But it doesn't matter. I could put it in for any equation. Either this one, this x right here, or I could put it in for this x right here. Everybody see that? Yeah.
If you were to put it in for the 6x minus 2y, would you still multiply by 2?
No, because it's you put it into the original. Forget the red after that, okay? The only reason we multiply by the 2 is to get to this right there. When you put this back in, then you're not doing that times 2 thing. Okay, you just put it back into the original problem. So our original problem looked like this. Oops. Okay? So this is what you're putting that x in. All right? And which one do you think is the easiest? Look, it's 1/3. You're like, oh, 1/3. I hate that. It's a fraction. But really, they rigged this thing for you to make it pretty easy. Because if I put a 1/3 in for x, what's easier? 3 times 1/3 or 2 times 1/3? They're both just as easy, but the 3 times 1/3 I think is easier. Because what is it? It's 3 over 1, right, times 1/3, right? Plus 4y, it will be a 1 in the next step, equals negative 1. See, that just becomes a 1. Doesn't cancel out, does it? Becomes a 1 because it's being added to something else. So you got to make sure you keep that in mind. Subtract 1 from both sides, right? And you get 4y equals negative 2. Divide both sides by 4. Y equals negative 1/2. So that's your y. Now you put it all together, make an ordered pair out of it. What do you get? 1/3, comma, negative 1/2. That is your answer right there. You okay with that? They don't get a whole lot harder than that. What will happen is you'll get something like this, and you're not just going to multiply one of them. Remember, we multiplied that by a 2? Yeah? You're going to have a situation where you're going to have to multiply both things by a certain number. Okay? I don't have one off the top of my head. I don't have one written down. But I don't know. This won't come out nice and pretty, I know, because I'm just making these numbers up. So you could have something like this. You could have 5x plus 7y equals, 13. And then you could have 2x minus 3y equals 7. Again, I'm not going to work this all the way out to the end because it'll probably come out really ugly. But let's just talk about the steps. If you had something like this, you could get rid of the x's or you could get rid of the y's. It really doesn't make any difference in this situation. I got a plus and minus. Let's get rid of the y's, right? I already got a plus and minus, so I don't have to worry about multiplying by negative. So what do I do? I got to make that the same number. So when I add them up, they'll add up to 0. They'll cancel out. Vicky, what are you going to say? No? I thought you had it. You probably see it though, don't you? What number can I make both of these? 21. Exactly. Okay, I can make those 21, can't I? So what would I have to do to that 7 to make it a 21? Multiply it by 3, and then you do the other one. And then what do you multiply that by? A 7. Everybody see that? Again, this probably won't come out nice. But then you do the distributive property, and then you'll find out that the y's actually cancel out. Shh, break. Okay? So that's about as hard as it gets right here if you had something like that. And my guess is they'll probably give you a couple of those on the homeworks. I mean, I don't have every homework problem memorized. I just barely looked at it. But that's what you would do, right? And then you would just do the whole thing. Distribute that through, multiply that. Then you would cancel out the y's, solve for x, plug it back in, solve for y, boom, you're done. That's it. All right. I'm only giving you, actually, you know what? I made this too easy. I don't know what I was thinking when I did the lesson plans. I should have just given you the whole entire thing. But I didn't. So I'll keep what I said I was going to do. So on the lesson plans is correct. All right. So you're only going to do, I think you're only doing graphing, I believe. Somebody look. Anybody got the book open? Yeah, it's 14 and 19. And I believe these are just graphing. All right, so I think these are just graphing. All right, and then tomorrow in class, I'll give you part B, and part B I'll write it down just so. I gave you the thing. I don't need to write it down. Yeah, that's fine. Good. All right, so that's it. You got like 12 minutes, 13 minutes. All right, so let's start working on it. All right, for those who have to do corrections, let's do them tomorrow because we're going to have the whole class because we've already taught the lesson. We'll have the whole class for you to work on the homework. And then for those who have to do corrections, I'll let you do the corrections. All right, I can show you what you got.